Hi everyone! Today we're going to continue with classification, and we're going to look at decision tree. So that means how to build a tree that can help you make decisions. Decision tree is actually a category of methods, and in general, when you're building a tree, that means you want to build a tree of rules, and the tree determines the sequence of rules that you want to check in order to make a decision of the labels for a data instance. For example, let's say you're a little kid and you want to know whether you want to play outside or not. So you may use a decision tree to figure that out. For example, you either want to play or not play, and the first rule you may want to check is the temperature or the weather outside. So such as whether it's sunny, overcast, or rainy. If it's sunny, then the next rule you may want to check is the humidity. So is it dry enough? Like let's say under 70. If it's dry enough, then you would decide to play. If it's not dry enough, over 70, then you do not play. So that means we'll pass the data instance through the tree starting from the top. And then you go through a set of rules, and the final outcome or final label is the majority class at the bottom. So every single decision point in the tree is called a tree node. And the final decision tree, so that means the points at the bottom are the leaf nodes. Before we go into the details of decision tree, I highly recommend that you take a few minutes to go through an interactive demo to look at how a tree is built from data to distinguish homes in New York from homes in San Francisco. And after that, we'll come back and look at the details of what you need to pay attention to when building a tree. So like the case of KNN, when you are building a decision tree, you need to figure out what are the things to learn, how to learn them, and also to look at how the cross-validation would play a role in the learning process. So for tree, the things to learn is what we call the tree structure. So that means how many branches there are, what's the fan out, and so on. And the way to learn it is to greedily minimize the overall classification loss. So that means how do you optimize for accuracy. By greedy, we means we want to make the best decision that we can at every single point. So that means we want to determine the best next steps when we are building the tree from the beginning, starting from the root node. So in the beginning, we only have a root node, so there's no branches. And at that point, we want to know how many branches we want to have. For example, in this example on the right, we say we look at outside weather. So is it sunny, overcast, and rainy? So in this case, it's pretty easy in that you already know the three possibilities. But let's say for humidity, you will need to determine what's the split point. So meaning, should we split at 70, or should we split on 60, and so on. So every single time we add a tree node or decision point, we just keep it as it. So that means we do not keep track, backtrack. And we will keep the parts that's built already as is. And the decision that we make is to just figure out what's the best next steps. So in other words, when we're optimizing something greedily, we're only looking at what's the best local decision. So that means we don't globally consider all possibilities. And the reason for doing greedy learning is so that we can cut down the training time. And also in practice, this strategy actually worked pretty well, giving a very good tree with very good accuracies. And the role for cross-validation here is to help us figure out the best size tree and also what's the best split point and so on. When building a tree, there's a few important considerations. The first one is how to determine the best split point of a chosen attribute, such as for humidity, should we split on 70 or should we split on 60? And the second consideration is which attributes to split on. So that means for a decision node, which attribute should we be using? And the third one is when do we stop? So as you may know, we can actually keep splitting until we have enough rules to really classify every single point in the training data set with 100% accuracy. But that's not really what we want, because that would be overfitting to our training data, and so that the tree would not generalize. And the fourth piece is how do we do cross-validation during the decision tree training. So we'll first look at the first consideration, which is choosing the split point. So to choose a split point, we need to figure out first what is the type of the attribute. So there are three primary types of attributes: categorical, ordinal, and contiguous. A very interesting thing about the decision tree is actually no matter which kind of attributes, we would create branches that are very similar. For example, for categorical attributes, such as looking at the genre of songs, like rock, classical, and pop. So this is the simplest case, because we can just have one branch for each of these categories. And for ordinal attributes, such as achievements, like platinum, gold, and silver, so here we have order, but in decision tree, actually, we don't really care about the ordering. So that means, in this case, we can just have one branch for each of the achievement types. For contiguous attribute, what we do would actually be determining the split point. But once we determine the split point, then everything looks the same as in the case of categorical attribute and ordinal attribute. For example, here we can say we look at the song duration. So we can say, well, let's split at 500 seconds. So if it's shorter than 500 seconds, we say it's a short song. And if it's longer than that, we'll say it's a long song. So at the bottom, you'll see that no matter which type of attribute we're looking at, actually we'll still have all the different branches, and they all look pretty similar. So that's actually a nice thing about decision tree, because that means it can handle all types of attributes in the same way. To evaluate the quality of a split point, we'll use a loss function. Remember, a loss function is a way to measure or to penalize mistakes. So let's say we only have two branches at a particular decision point, left and right. Here what we do is to say, if we are splitting a particular value for attribute D, then we would measure the mistakes on the left branch and the mistakes on the right branch. And ideally, we want to pick a split point so that these total number of errors, or the total loss, is smallest as possible. And there are different ways I can measure mistakes. For example, we can use misclassification rate, you can use expected loss, or cross entropy. So previously, we talked about how to evaluate an attribute split point, but we haven't talked about how to choose that attribute. So one common way to choose an attribute is to pick the attribute that gives you the maximum improvement in training loss. Another way is to pick the attribute that gives you the highest information gain. So intuition is that an attribute with the highest information gain would help you the most rapidly describe an instance. So in other words, if you pick an attribute, it can help you reduce the uncertainty in your decision as much as possible. That's probably a very good attribute. So, which also means that by picking the ones with the highest information gain, likely your tree is going to be much shallower. So for an excellent refresher on information gain, I highly recommend you to look at the lecture slides from a Carnegie Mellon class. The link is shown here. Remember that we can keep splitting or creating more nodes in a tree until we can get 100% training accuracy. But that is not really what we want, because then we have a tree that overfits our training data. So that means we want to stop earlier on so that we have a more shallow tree that will generalize well to unseen data. So there are a few strategies to determine when to stop. So one is to look at the purity of the leaf nodes. For example, you can stop, obviously, when all the points in a leaf node belong to the same class. Or in another scenario where you have two classes, but those points in those two classes completely overlap. So that means you don't really necessarily know how to split anymore, and then you just output the majority class at this leaf as the label. You can also stop the splitting based on the number of points. So let's say if a node contains points fewer than a certain threshold, then you can also stop. Also, using the notion of purity, you can also say as long as the node purity is higher than a certain threshold, you will stop. Another way is to look at the overall training loss in the tree that we built so far. So you can say if the overall training loss is still above a certain threshold, or it doesn't really improve, then you stop the splitting. So in decision tree, you learn that there are quite a few things you need to figure out. And actually, there are different ways to differentiate between these different kinds of parameters, or different things you need to figure out. So there's a notion of model parameters and also hyperparameters. So for hyperparameters, in the example of k and n, k would be the hyperparameter, or the similarity function too. So these are the things that you may not really know what they are until you try them. So for decision tree, it will be the number of nodes in the tree. In decision tree, there are two types of parameters. One we call model parameters, or just parameters, and another one we call hyperparameters. Hyperparameters are probably more familiar to you. For KNN, K and also similarity function are hyperparameters. So those are parameters that you will need to try or to figure out. And for decision tree, the number of nodes in the tree would be a hyperparameter. So for example, you can set, I want to stop the splitting once the tree has a certain number of nodes. So for this, you don't really know unless you really tried it. And to determine these hyperparameters, you can use cross-validation. Another way to do it is to do something we call grid search. So grid search is a very fancy way to say essentially trying all combinations. So you're like walking through the grid of all combinations. And of course, that's very expensive, so which is why there's also a variation of it we call random search. So that's also a random, very fancy way to say that essentially you're only trying a subset of the combinations. Another parameters is we call model parameters. So that means these are things that you can learn, estimate it, or compute it directly from data. For the case of decision tree, this could be the attribute you want to split on, or the split point for an attribute. The reason we say that these can be directly computed is because, let's say we use the entropy-based method, then we can just compute those without having to try all possibilities. Overall, for decision tree, they are quite easy to implement, very interpretable because you can see all the rules in the tree. And also it's very fast during test time. So meaning once the tree is built, then you can pass data instances through all sets of rules very quickly. And also a very nice thing is that it can work with different kinds of attributes like ordinal, categorical, continuous, and so on. And in practice, it also works pretty well. Some caveats, though, is sometimes people say it's too basic because it's a set of rules. But in practice, it's actually OK as long as they work really well. Building trees can be expensive because there are a lot of things you need to consider. Let's say it's a split point, which attribute to pick, and so on. And cross-validation can be tricky because you may do something we call node-level cross-validation. So at every stage of building the tree, you need to figure out different parameters, and also you need to do cross-validation at those different node levels. In this video, we look at a very popular classification model, decision tree, and also look at some of the important considerations, such as which attributes to split on, and also split points, and so on.